Hello everyone, welcome back. Today we have 1578 minimum time to make rope colorful. It says here Alice has end balloons arranged on a rope. You are given a zero index string colors for colors of I, where each color is the color of the ith balloon. And Alice wants the rope to be colorful, which means she does not want two consecutive balloons to be of the same color. So the main idea is here, it looks like we have some balloons where each character represents a balloon color. So B is one color, A is one color, L, this can be the same color. And the idea is to have only characters which are unique from its left and right neighbors. So if we look at the first one, B, nothing on the left. So let's say that it can continue. And then A, left is not the same. L, not the same. Once we get to this L at index 3, we see that it is duplicating the previous L. The previous balloon takes 3 seconds to pop. The current balloon takes 4 seconds to pop. So ideally, we want to spend as little time as possible. We are to return the minimum time Bob needs to make the road colorful. Bob is the friend helping Alice get a colorful set of balloons. So in order to get the minimum time needed to get colorful balloons, we want to pop the one that takes less time, which happens to be this guy. Okay, so let's say we initialize some variable time. This will be the time needed. Then at this point, since we popped this balloon, we can add 3 over here, and we can keep the one that's larger or longer, which is 4, at the current index position, which is already 4. So we'll keep this as a 4. This one stays as is, and this one gets popped. Okay? Now we're here and we see that, you know what? This still duplicates the previous balloon. So once again, we have two values. We want to spend as little time popping. This one is the lesser time. So let's add 3. Let's add 2 to 3, which becomes a 5. And we want to carry over whatever takes longer. So this one can now become a 4, this one's now a 4. And once we're here, we see that once again it is duplicating and this current time is less than the previous time. So we want to spend as little time as possible. And so we'll add the lesser time of 1. And then now we have 6, and we want to carry over whichever is the longer time. And at this point, you notice we have 4 L color balloons, of which we ultimately carried over the one that had the longest seconds to pop. And it did not matter where, if it's the first one, the middle one, the last one. Ultimately, using our logic, we were able to carry over the longest value to the end. And now, when we go to the next color of O, we're at a point where we're no longer duplicating the previous balloon's color, so we can continue. But then once again, once we're at index 7, we see that yes, we are duplicating the previous color, and the lesser of the two colors is 2, so let's add this, as in we pop this one, and now our total pop time is 8. We can continue carrying over the 3 because it is the longer of 2 times. And then once we're at index 8, we're still duplicating. Again, we want to take the lesser of the 2. So 3 is less than 4. We want to spend as little time popping balloons. Now we've spent total 11 seconds popping balloons. And this one is the 4 because 4 is the longer of the 2. Now, what if the next one is less? Well, here we go. This is an example where it's less, where the previous time, so this duplicates the previous color and the previous time is longer than the current time. So we want to ultimately continue carrying forward the longer value and spend as little time popping balloons. So let's add that time and carry over the longer time here. Okay? And we're once again at another zero or O colored balloon, and then we pop the one that takes less time to pop. This now becomes 15, and then here we carry over the longer time to pop. Okay, and as you can see, even from these same colored balloons, we ultimately carried over the longest time to the end. And once we hit the actual end of all the balloons, we see that it does not duplicate the previous color, so we're fine, and this is our answer. The main idea is actually quite simple. We want unique adjacent colored balloons. BA is fine. We have duplicates here of which we take the lesser times to pop. We want to spend as little time popping. When we have 4, we need to pop 3 in order to be left with only 1. So we want to pop the ones that are less times, which ultimately means that we end up carrying over the balloon that takes the most time to pop. And once again here as well, we have all these duplicate adjacent balloons, of which we want to spend as little time popping balloons, so we keep on adding whatever is less of the 2 that are adjacent, which means ultimately we end up carrying over the time that's longer to the end, and we use up the times which are less in our result variable. All right, so let's translate this to code. Okay, so now for the code part. What did we do? We had some running variable time. Just for clarity, let's call it use time. And we initialize it to 0, and we iterated every balloon in our input balloons or colors. So for I in range, and we want to start from the second one because the first one is unique as itself. From the second one, we can see if the current balloon duplicates the previous one. Also, if we start from 0, we would be going out of bounds. So from the range of the first to the end, we can say if and only if the colors of the current balloon, so if the current balloon's color matches or duplicates the balloon just before it, then we know these are not unique balloons. These are adjacent balloons that share the same color. So first we want to check, we want to find out which one takes less time to pop. So it would be minimum of whatever is the needed time of the current balloon to pop and whatever is the needed time to pop the balloon that came just before it. And this is just the reverse of this guy. And whatever takes more time, we'll save it here. And ultimately, we want to spend as little time as possible in popping balloons. So we can add whichever takes less time to our use time in popping balloons to make these all unique adjacently. And then we can remember to update whatever is the current position. So if the current balloon happens to take less time to pop than the previous balloon, it doesn't matter. We want to remember the longer time because essentially we want to save our time. So we want to carry over the time. We don't want to use the time by adding it here. We want to carry over the longer time whenever possible. Let's add that. And then the time of the current balloon, let's say is whichever one took more time. So essentially these two balloons are the same, just that one takes longer to pop than the other. Okay, and then at the end, actually we can just return use time. So let's give that a go and submit. And this one, we are running linearly. So time is 11 and space. Looks like we're just using constant variables, so space is constant. And that's once again 1578 minimum time to make row colorful, where the idea is pretty simple. We're essentially just taking the smaller of the adjacent duplicated colored balloons times, adding it to our use time because we want to pop all the duplicating balloons with as little time as possible, and thereby we carry over whichever is the longer taking time. Thanks so much. Happy coding. See you next time.